Hey guys, so I wanted to follow up and talk a little bit about this idea of neutralization and talk a little bit about the wording of it. We call it neutralization, but it's really kind of a misnomer. If you're thinking that every time you add an acid and base together, you end up with neutral substances that have a pH of 7, that's not what neutralization is. Neutralization is how acids and bases can, but there's some conditions, and that's typically not the case that you end up with a pH of 7. And so it depends on several factors. It depends on, first of all, the strength of the acid or base, which is what we're going to talk about today. Also is determined by the concentration. So what we're going to talk about is the idea of strength. Not all acids and bases have the same strength. And so it really kind of depends on the nature of the acid. There are some strong acids, and those are some strong acids that just really simply you just have to be able to identify them. They are hydroiodic acid, HI, hydrobromic acid, HBr, hydrochloric acid, HCl, nitric acid, which is HNO3, sulfuric acid, H2SO4, and finally perchloric acid, which is HClO4. So those are the 6 strong acids. As far as anything else, if it's not one of those 6, it's considered to be a weak acid. A strong base. Strong bases are bases that are composed of bases that have metals from group 1 or group 2 of the periodic table. So for example, sodium hydroxide would be considered to be a strong base because sodium is from group 1. Calcium hydroxide would be considered to be a strong base because calcium is from group 2. Okay, so those are strong acids, strong bases. Now, what do we mean by strong? That means that when you put them in water, they completely dissociate, and you get an actual, for every molecule, you get an actual ion. For an acid, you would get hydronium or hydrogen ion. For a base, you would get a hydroxide. And so when you add acids and bases together in neutralization, we know that kind of the template for that reaction is that for an acid and a base, you expect to get a salt and water, H2O. So it kind of depends upon the strength. When acids and bases are both strong, then you're more likely to have neutralization take place, and they're more likely to balance each other out or neutralize each other. But if they're not the same in strength, then you're going to end up with a salt that may be acidic or basic. It's almost like what's left over. So for example, if we have a strong acid and a strong base, then we expect to have what we call a neutral, of course it helps if you spell that right, neutral salt. And that would mean that the pH may be around 7, okay? It's not going to be acidic or basic. It's going to be more neutral. If you have, for example, if you have unbalance between the strength of the acid and base, then you're going to have leftover. So let's say, for example, you have a strong acid and you have a weak base. Then think about it as strength, that literally, if this is strong, it's going to overpower the base. And some of that is also going to be left over, and we'd be left with what we refer to as an acidic salt. And that would mean that the pH of that salt, dissolved in the water in this case, would probably be below a pH of 7. Let's say, though, if you had a weak acid and a strong base, then when you combine those two together, then your salt is going to be left behind because of the fact that the base is stronger. It's going to power. And even though you end up making a salt, it's going to be basic in nature. Okay, so those are some things that you, of course, would want to consider. And just a quick follow-up, if we were to take an acid and base, remember that acids start with hydrogen, and then you're going to have some anion attached to that. A base is something that's going to end in OH. So let's say, for example, I picked one of these strong acids, maybe HNO3. And of course, that's strong. And let's suppose I pick something like, I don't know, maybe, here's a good one. How about nickel hydroxide? Now, nickel is a transition, so it's clearly not in group 1 or 2, so it would be what we consider to be a weak base. Now, when we go to form our salt on the other side, then the H and the OH form the water, and then what's left over, in this case, the nickel, would form with the nitrate, and we get nickel nitrate. I'm thinking that, I might be wrong, but I'm pretty confident that nickel is 2. So we might better make that a 2. 2 hydroxides there. And we'll put a 2 there as well. Okay, and so what we're going to end up with, if we're looking at this salt, we've got a strong acid with a weak base, then we're going to end up with an acidic salt. Okay, so this would be nitric acid because it's a polyatomic, no hydro, nitric acid, nickel hydroxide. We're going to produce water and nickel to nitrate, and that's going to be an acidic salt. Okay, so there you go. Have a go at the handout, and then we'll go over any questions that you have later.